Okay, so and now, although we basically have already seen it in the last video, I wanna show an example of this procedural swarm function where we basically just use a curl noise to drive the position of some points. And it's really quite fascinating what you can do with that. So the core idea is really simple. You say the position of each point is completely overwritten by the position of the curl noise based on the current position. Now this alone will just give you some random positions, well, curl noised positions, but the idea here is that you then add an offset, in this case, let's say by time, and the whole thing moves around, and you can already see what this does. Depending on the size of your setup, you can actually create some interesting looks to this. So first of all, let's be able to control the speed of this. So we take the time and we just multiply it by a simple multiplier, and we call this speed, of course. And this way we can control, okay, now the speed is 0. So let's move this up, and now it's really slow. I don't know why you would do that. Or super fast, maybe something like this, which is of course ridiculous. But this is nice that you can control the speed. That's easy to understand, but the next thing that is important is the size, and this gives a very important difference in the feel of the whole thing. Because if the size is 0, then it looks like this. All the points basically move in the same direction. And if we have a relatively small size, and the idea here basically is that the noise is so small that each point gets a different direction. Let me quickly visualize the whole thing. Currently, the velocities are so the size of the whole thing is so small that it looks like random basically. But if I move this up, you can actually see what we've seen before. This is basically visualization of a normal curl noise. And the idea here is if you make it really small, then it's still a pattern, but it's so small that it feels way more chaotic. And this is what we see here. Each point has a different direction basically, and it feels very chaotic. When I now increase the size, just like we saw before, then basically the waves get bigger. And the interesting thing here is more points follow the same direction because they are, close to one direction. They share a direction, so to say. And if I make this really big, you can see that they become one almost. And the idea here is that when we go back to the visualization, if you make the pattern here, the wave pattern, big enough, then a very big area will, like this here, will cover the same direction. And this is basically what's happening. And when you do it so much that the whole area has basically one direction, then it feels like all those points move in the same direction. And of course, this is too strong. I mean, maybe you need something like that. I don't know, some kind of magic effect or something. But depending on your scale, maybe something in this direction can look like they roughly follow the same direction, but are still independent. And this looks a little bit like a bird swarm. If you just want a couple of insects, which are a bit more random, then you just lower the size. And finally, of course, this curl noise creates a vector between -1 and 1 in the elements. So by multiplying the whole thing, we can make basically our area bigger. So this would be amplitude again, but it will be visible in simply the area that we cover. Small area, bigger area, or maybe very big area. And then in relation to that, the scale controls the overall feel to it. And now, of course, this makes a bit more sense even when you copy something to it. So let's say here, I created some really, really simple insect or something. It doesn't really matter because it will be tiny, but at least you can see that it has wings. And if I just copy it to points by itself, it will still look a little bit weird. And the reason is, maybe I can scale it up a little bit to show that, they all have the same orientation. So they change the position, but not their orientation. And that looks, of course, a bit wrong, even though you can already see where this is going. Now, the cool thing is the copy to points, if you don't give it N or up, it will actually follow the velocity. So we can use a trail node here to calculate the velocity, since our point number isn't changing, it's constant because it comes from a consistent source, then the velocity can be calculated correctly. And this means now that our creatures here, which are aligned toward Z, which of course you can't see again, but this is the Z-axis. There it is. This is the Z-axis. So that means it looks as if our animals here will move in the direction of the velocity they move to. So obviously what I should lower now is the speed, because it's a bit too fast. And now you can see it feels almost a little bit as if those are, you know, bird flocks or something. And again, if you make it smaller and maybe faster and maybe the whole thing a bit smaller, it looks more like insects. And I could, of course, as well increase the amount of points. So it's a really cool setup. I really like what you can do with that. Without any animation or simulation, it is completely driven by VAX. So yeah, I hope this was helpful. I find it a really fascinating technique. So yeah, thanks very much and see you later. Cheers.